Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course. States of matter. So today we begin with lecture 3 from the course, but make sure you watch the previous ones before doing this one. In the last lecture, we learned about the various intermolecular forces, and among them one force was the dipole-dipole interaction, the interaction between the polar molecules. So when the opposite ends of two polar molecules, they come closer to one another, they feel an attraction toward itself and they come close to each other, which we call as the dipole-dipole interaction. And then in the last lecture, we also learned that there is a special type of dipole-dipole interaction, which we call as the hydrogen bond. So it is this hydrogen bond that we will be discussing in detail because this is a very important topic. It is an important topic for your examination because what you will be seeing when you're going to study in detail the various courses related to organic chemistry as well as inorganic chemistry, you will be finding plenty of examples where among the molecules you are going to see the attraction between them, which we call as the hydrogen bond. So this is going to be really very important for you. Giving you one example of hydrogen bonding, well, we all drink water, right? So in water, if we did not have water, well, we would not have existed even. And the liquid and the solid states of water, they are essentially existing because of this hydrogen bonding. So you can understand why it is going to be so important for us to study about this hydrogen bonding. So let us talk about this more in this lecture. So quickly recapping what we have learned in the last lecture while we were talking about the dipole-dipole interactions, that they are the interactions, they are an attractive force which is present between the polar molecules. And now when we talk about the polar molecules, for example, we have the HF molecule. So the HF is a polar molecule, another HF molecule, and again a polar molecule. So when these are attracting each other, we call this as a dipole-dipole interaction. But now when I am labeling this attractive force between them, I am calling this as a hydrogen bond. So let us understand this special type of dipole-dipole interaction, the hydrogen bond. So hydrogen bond, this is the attractive force which binds the hydrogen atom with the electronegative atom, fluorine, oxygen or nitrogen of the same or a different molecule. So here this dipole-dipole interaction which is occurring between a hydrogen atom and a electronegative atom of a different molecule, we call this as a hydrogen bonding. We will see an example where you will be seeing the hydrogen bonding occurring in the same molecule as well. But when we talk about the two HF molecules, it is not the force which is between hydrogen and fluorine of the same molecule. In the same molecule, hydrogen and fluorine, they are forming a covalent bond, right? This covalently bonded hydrogen of one molecule which is having an attractive force to the fluorine, which is an electronegative atom of the other molecule. Okay, so please be very clear of this, that when we have highly electronegative elements like nitrogen, oxygen or fluorine, which are attached to a hydrogen atom forming a covalent bond, the electrons of the covalent bond, they are shifted towards the more electronegative atom, right? So we have this covalent bond between hydrogen and fluorine, but the sharing is not equal between both the atoms. Fluorine being more electronegative, that pulls the electron pair towards itself. There is more electron density towards this end, which we denote by the partial negative charge. This is going to be less electron density area, so this is denoted by the partial positive charge. So when this hydrogen of the other molecule, which is also going to have a partial positive charge on it, is being attracted by the partial negative end of the HF molecule, that is the fluorine end. This attractive force, we call this as a hydrogen bond, right? I hope this is clear. The partially positive charged hydrogen atoms form a bond with other more electronegative atom. Okay, please do remember, we call this as a bond, but still it is not a bond. It is a bond, it is not a bond. This is something very confusing, but please do understand the dipole-dipole interactions. These are van der Waals forces of attraction, and van der Waals forces of attraction, they are weak forces. But when we call something a bond, this means that this should be a strong attractive force. Just like when we talk about the ionic bond, the covalent bond, these are very strong forces of attraction. So hydrogen bond is a force of attraction which is not as weak as the dipole-dipole interactions, but not as strong as the covalent or the ionic bonds. Okay, so these are weaker than the covalent bonds but stronger than the van der Waals forces of attraction. So I hope you will remember these things, that it is the hydrogen of one molecule attracting an electronegative atom of the other molecule by a hydrogen bond. When we are going to see it in the same molecule, I will be showing you a bit later, but for now, at least this part of the term you understand very well. So please do remember that the hydrogen bond, this has resulted from the electronegativity difference between the bonding atoms, resulting in the formation of a polar molecule having electrostatic force of attraction. So the hydrogen bonds you will be always seeing where we have polar covalent molecules. This will never be found in the non-polar covalent or the ionic molecules. Okay, so please do remember, this is very important, that the hydrogen bonds, they are formed only in the polar covalent molecules. And the magnitude of the hydrogen bonding, this is going to be maximum in the solid state and minimum in the gaseous state. Why is it going to be so? Because this is a force of attraction. So if the molecules, they are closer to each other, the attractive forces are going to be more. If they're far away from each other, the attractive forces are going to be less. And it is in the solid state that the molecules, they are going to be close to each other. So they are going to experience stronger forces of attraction. The hydrogen bonds, they are very important to us. Why we study these are because they have a strong influence on the structure and the properties of the compounds. And in fact, it is going to be the next lecture where I am going to talk in detail about all these applications of the hydrogen bond. How the hydrogen bonds, this is influencing the properties of the various compounds. So now let us learn the conditions essential for hydrogen bonding. And these conditions, once you have learned them, they are going to help you differentiate between any other dipole-dipole interaction and hydrogen bonds. So this is very important for you to understand these conditions. So the first we have is that hydrogen should be covalently bonded to a highly electronegative atom like fluorine, oxygen or nitrogen. You have already seen the case where in the HF molecules, hydrogen, this was covalently bonded to fluorine, and this hydrogen this was participating in the hydrogen bonding, right? So a hydrogen covalently bonded to fluorine, to oxygen or nitrogen, this hydrogen can participate in hydrogen bonding. Now, one thing that you can ask me over here is that nitrogen and chlorine, they have similar electronegativity values. Why is it that we have not included chlorine in this list, right? So chlorine is also an electronegative atom. It is having electronegativity values similar to nitrogen, but yet we are saying that hydrogen covalently bonded to fluorine, oxygen or nitrogen, this participates in hydrogen bonding. So for this you have to understand the second condition. And the second condition says that the electronegative atom should be small in size and it should have a lone pair of electrons. Again, the lone pair of electrons is present on fluorine, oxygen, nitrogen as well as chlorine. But now this part over here which says the electronegative atom should be small in size, this makes chlorine out of the picture. Why? Because these three, they are all the second period elements, whereas chlorine, this is a third period element, this is much larger in size. So generally what you will be seeing is that hydrogen, this will be participating in hydrogen bonding only when this is covalently bonded to fluorine, oxygen or nitrogen. Although when you are studying organic chemistry, you will be seeing examples where carbon and chlorine bonded hydrogen will also participate in hydrogen bonding. But those examples, they are going to be less. They are going to be some special examples that you will be studying. One example I will be just now showing you as well. But in general, what you will be seeing is that hydrogen bonded only to fluorine, oxygen or nitrogen, this is going to be participating in hydrogen bonding. Okay. So now when we talk about the strength of the hydrogen bond, based on these two conditions, the strength of the hydrogen bond is directly proportional to the electronegativity of the other atom. More is going to be the electronegativity, more is going to be the polarity of the molecule, and more is going to be the strength of the hydrogen bond. Similarly, when we talk about the atomic size of the electronegative atom, smaller is going to be the atomic size of the electronegative atom, more is going to be the strength of the hydrogen bond. Now, what do we conclude from this discussion is that the decreasing order of the electronegativity of fluorine, oxygen and nitrogen, these are the values over here. So fluorine is most electronegative. So hydrogen, forming a hydrogen bond with fluorine, this is going to be having the maximum strength, then the H and O and then H and N. So these comparisons we will be doing when we are going to study the examples for hydrogen bonding. Okay. Now, when we consider the other side, the other condition of the atomic size, more is going to be the atomic size, less is going to be the hydrogen bond. So here also nitrogen, this is the maximum size. So the weakest of all these three hydrogen bonds is going to be when the hydrogen is bonded to nitrogen. Okay, so the strongest is going to be the HF hydrogen bond, then the HO and then the HN hydrogen bond. Okay, I hope this is clear. Now, as I was telling you that there is going to be examples that you will be seeing hydrogen covalently bonded to carbon or chlorine also participating in hydrogen bonding. So let us just see one example. The rest we will be discussing when we are talking about these further in the courses on organic compounds. Okay. So here we have hydrogen bonding occurring in the HCN molecules. Now, here what you are seeing, hydrogen, this is covalently bonded to carbon. And generally what you will be seeing is whenever a hydrogen, this is covalently bonded to carbon, these have almost similar electronegativity values. There is no uh, polarity in this molecule. There is going to be no charge separation over here. There is going to be an equal distribution of the electron cloud, and the shared pair of electrons, this is going to be equally shared between carbon and hydrogen. But when we see this molecule, this special molecule, HCN molecule, what are we seeing is that this carbon, this is having a triple bond with the nitrogen atom, right? So when this is a triple bond over here, this carbon is going to be sp hybridized, and when it is going to be sp hybridized, there is going to be a more s character for this carbon, and when there is going to be more s character, more is going to be the electronegativity of this carbon. And when this is going to be electronegative, so the hydrogen which is going to be bonded to it, it is going to have a partial positive character, and therefore this will be able to participate in hydrogen bonding. Okay, we will be talking more about this while we are talking about the organic compounds. So there you will be able to understand all this much better. Okay, do not worry if you've not understood. Just for an example, I wanted you to have an understanding that there you will be seeing certain cases where carbon bonded to hydrogen. Here this hydrogen is also going to participate in hydrogen bonding like this. Okay, so we will be seeing certain examples, but in general it is going to be hydrogen covalently bonded to fluorine, oxygen or nitrogen. Okay. Next we have is the types of hydrogen bonding, and we have two types of hydrogen bonding, the intermolecular and the intramolecular hydrogen bonding. And the word inter and intra, it is very easy to understand if you take the example of an inter-school competition and an intra-school competition. Inter-school competition means that it is going to be a competition where different schools will be participating. And in intra-school competition, it is among the students of the same school. So we have over here intermolecular hydrogen bonding, where hydrogen bonding is going to be taking place among molecules. Okay, but when we have the hydrogen bonding occurring in the same molecule, we call this as a intramolecular hydrogen bonding. Okay, and in the intermolecular, we can a homo intermolecular and a hetero intermolecular hydrogen bonding. Homo is going to mean same molecules, hetero is going to mean different molecules. So let us understand all this with the help of some examples. So the first type of hydrogen bonds, they are the intermolecular hydrogen bonds. So inter means different molecules. So formed between two different molecules of the same or different compounds. So what do we mean by this is that we have the hydrogen atom of one molecule forming a hydrogen bond with the electronegative atom of the other molecule. So this is a hydrogen bond, and please do remember we denote the hydrogen bond by a dotted line, whereas the covalent bond, this is going to be denoted by a solid line. Okay. Now, when we have the intermolecular hydrogen bond, it can be between molecules of the same kind like we have in the case of the HF molecules, but it can be between molecules of the different kind as well. So based on this, we have two types of intermolecular hydrogen bonding. The first is the homo intermolecular hydrogen bonding. So homo means same. So here the hydrogen bonding is between molecules of the same compound. For example, you have in the case of the HF, all the molecules, they are of the same kind. Similarly, we have the hydrogen bonding in case of water molecules. So water molecule, this is a polar molecule. And in this, hydrogen atom is covalently bonded to electronegative element, that is oxygen. So here when the covalent bond is going to be formed, again the electron density is going to be towards oxygen. So there is going to be a partial negative charge on this, a partial positive charge on hydrogen. But when we have the water molecule, the oxygen is covalently bonded to two hydrogen atoms. So the two hydrogen atoms, they will be having a partial positive charge on each, and as the molecule as a whole is completely neutral, so this will be having 2 unit of partial negative charge. And as a result, when it is going to come close to another water molecule, the oxygen atom, this can form two hydrogen bonds with the two hydrogen atoms of the adjacent molecule. Okay, so I hope you can understand over here why we are showing this as two lines, because oxygen, this can form two hydrogen bonds, right? So the hydrogen bond between one hydrogen and oxygen and the other hydrogen and oxygen. So this is the case of a homo intermolecular hydrogen bonding, all same molecules but different molecules. Okay, the next we have is the hetero intermolecular hydrogen bonding, and over here it is hetero means different. So the molecules now, they are going to be different. Hydrogen bonding between molecules of different compounds. For example, we have alcohol and water. So what do we see over here is this is an alcohol molecule. You will be studying more about this in organic chemistry, but what you can understand this is that the formula for this is going to be ROH. And when we have ROH, the hydrogen atom, this is covalently bonded to the electronegative oxygen. So this is one condition that is justified over here. The water molecule over here, again, this is having an electronegative oxygen, so the hydrogen of one molecule forming a hydrogen bond with the electronegative atom of the other molecule. So this is also a hydrogen bond that we see, but because these are different type of molecules, so this is hetero intermolecular hydrogen bond. Fine.
Next we have is the intramolecular hydrogen bonding. So intramolecular means in the same molecule, formed when the hydrogen atom is in between two highly electronegative fluorine, oxygen or nitrogen atoms present within the same molecule. Let us see this with the help of an example. You will be able to understand this better. This is a molecule which we know as ortho-nitrophenol. How we are going to draw the structures, how we name these compounds, you will be learning more in organic chemistry. This is an organic compound. But what you can see over here is this OH over here. There is a covalent bond between oxygen and hydrogen. So hydrogen is covalently bonded to an electronegative oxygen, right? So this can be oxygen, this can be a nitrogen, it can be a fluorine, but we are seeing this covalent bond between hydrogen and oxygen. And now in the near vicinity, in the same molecule, we have another oxygen atom. So this hydrogen, this is forming a hydrogen bond with the oxygen atom, and the molecule is the same, so we call this as an intramolecular hydrogen bonding. The hydrogen bonding taking place in the same molecule. Let us see one more example. This is salicylaldehyde. And this also what you can see is that we have an oxygen hydrogen covalent bond. So hydrogen covalently bonded to an electronegative element, right? And in the same molecule we have an adjacent to this in the structure. When you draw the structure of this, the oxygen is quite close to this hydrogen. So there can be an attraction between the electronegative element oxygen and the hydrogen. Okay, so this is also a hydrogen bond, and this is again occurring in the same molecule. So this is intramolecular hydrogen bonding, right? I hope this is clear. What is hydrogen bonding? What are the conditions necessary for hydrogen bonding? And what are the types of hydrogen bonding? So that would be all for this lecture. The next lecture we would be seeing the applications of hydrogen bonding, how hydrogen bonding is influencing the properties of various compounds. So again, this is going to be a very important lecture for that. Please do not miss the next lecture. Very important. And for that, what you have to do is simply subscribe to the channel, click on the bell icon. You would be getting the notification the moment we put up the next lecture for you. So see you again. Have a nice day. God bless you.